right, here's the video for notes 5-5, triangle congruence postulates. So a congruence postulate is just a way of proving that two triangles are similar without having to show that all three pairs of sides and all three pairs of angles are congruent. So the first postulate is called SSS, which stands for side, side, side. And side, side, side says if three sides of one triangle are congruent to the corresponding sides of another triangle, then the two triangles are congruent by side, side, side. So here's kind of a basic example. We can see that we have three pairs of congruent side. So we see that BC is congruent to YZ, AC is congruent to XZ, and AB is congruent to XY. So that's side, side, side because we have three pairs of congruent sides, which we can label with little s's. And that's enough to show that the two triangles are congruent, which would also mean that the corresponding angles would also be congruent. So let's take a look at an example here. So here we have our two triangles. So first thing we need to do is if there's anything that we can mark as being congruent that isn't already given to us, we should mark that. So for instance, I know that this has a shared side, so I can mark that shared side as being congruent. And I'm going to use 3 markings since we've already used 1 and 2. Okay, so from here, I see that I have 3 pairs of sides. I have my first pair, my second pair, and then my third pair, which is the shared side, which tells me that these are congruent by side, side, side. So what we need to do is we actually need to write out all of our congruent statements. So again, like I said yesterday, in the previous lesson, every marking must have a congruent statement. So I'm going to start with a 1 marking. So EB is congruent to, so I went EB is going to be congruent to DB. And then if we're saying they're congruent, we have to state the reason. Well, those are congruent because it was already marked, so that was given information to us. Okay, the next pair of congruent side I'm going to say is EA is congruent to DA. And that was also given to us. And then lastly, AB is congruent to AB. And we have to be careful because that wasn't given to us. We mark that as being congruent because it's a shared side. So as we see here, we have 3 congruent statements. The 3 sides as being congruent, which tells me that these 2 triangles are congruent, so we can write a congruency statement. So triangle EAB is congruent to, so make sure the order of the letters. So I went EAB, so I went down the 2, up the 3. So EAB is congruent to DAB. And since this is a triangle congruent statement, we need to make sure we use the triangle symbols. And we have to say why. So just like all of our congruent statements up here, every statement should have a reason. The reason that these are congruent, it's because of side, side, side. So we're going to say triangle EAB is congruent to triangle DAB by side, side, side. Okay, so the next congruence postulate is side angle side. And side angle side states that if 2 sides and the included angle of one triangle are congruent to the corresponding 2 sides and angle of another triangle, then the 2 sides are congruent by SAS. So as we can see in this picture, I'm going to label what's marked. That's a side. This is an angle. This is a side. Same thing here, side, angle, side. And for this particular problem, or for this particular postulate, the included angle must be the angle between the 2 sides. So this angle right here is called the included angle. So it can't just be any angle on the triangle. It has to be the angle in between the 2 sides. All right, so let's take a look at an example here. So in this picture, first thing I'm going to do is I'm going to mark my congruent angle. And the reason we know those are congruent is because those are vertical angles. And then I'm going to label the marked part. So that's a side, this is an angle, this is a side. Same thing here, side, angle, side. So now that I know it's side, angle, side, I'm going to write my congruent statements for all the congruent parts. So I'm going to start with a side. So I'm going to say XZ is congruent to AZ. And the reason that those are congruent is because that was given to us, that was marked. The next thing I'm going to write is the angle, since this is side, angle, side. So because this is, these vertical angles share the vertex, I should use 3 letters. So XZY. So angle XZY is congruent to, and then we have to go in the same order. So I went XZY, so I need to go AZB. And that wasn't given, those were vertical angles. Okay, and then lastly, the last corresponding side, YZ is congruent to BZ. And that was given, that was already marked. So then since that showed side, angle, side, we can write a triangle congruent statement. So triangle XZY. And since we named the angle with 3 letters, we can actually use that to name our triangles as well. XZY is congruent to triangle AZB by side, angle, side. All right, the next congruence postulate is ASA, which stands for angle, side, angle. And angle, side, angle states that if 2 angles and the included side of one triangle are congruent to the corresponding angles inside, of another triangle, then the 2 triangles are congruent by ASA. So in the previous problem we saw we had an included angle. In this case, it has to be the included side, so the side between the 2 angles. So on this picture, we can label what's given. That's ASA, ASA. And the included side is the side between the angles. So it needs to make sure it can't just be any side, it has to be the side between the angles. Okay, so let's take a look at our example. So in this diagram, there's no other marked information or no other information we can mark, so we're gonna label it angle, side, angle, angle, side, angle. And we're gonna write our congruency statement. So I'm gonna start with the angle. So angle X is congruent to angle A or angle G. And we can just use 1 letter because none of those vertices are shared. That was given. And now we're going to name the side XY. It's congruent to, so we went XY, so to the 2 to the 1, so I need to go 2 to 1. That's going to be GF. That's given. And then lastly, you have angle Y. It's congruent to angle F. And that was given as well. So there's the angle, side, angle to show ASA. So now we can write a congruent statement. So I'm going to say triangle XYZ is congruent to triangle. So XYZ, it's going to be GFE by ASA. All right, the last congruence postulate is AAS. So this might seem like it's the same as the previous one, but notice the side is in a different spot. So angle, angle, side says if 2 angles and the side not included of one triangle are congruent to the corresponding angles and side of another triangle, then the 2 triangles are congruent by AAS. So it's important that the side that is congruent is the side that is not included. So in this case, this is the side that is not included. It's the side away from the 2 angles. So on here we can see, we can label this as angle, angle, side, angle, angle, side. So you need to make sure you skip the included side in order for it to be angle, angle, side. So let's take a look at an example here. So in this example, there's no other information to mark since I don't see any vertical angles or shared sides. So if we label the marked parts as angles or sides, we can see that it's AAS. Same thing in the other triangle. And then we're going to write our congruent statements. So starting with angle M is congruent to angle T. That was given. Angle N is congruent to angle U. That was also given. And then lastly, we have side LN is congruent to VU. And that was also given. So from here, we can see that that's angle, angle, side. So these are congruent. So we're going to write a congruent statement. So I'm going to say triangle MNL is congruent to triangle TUV by AAS. All right, so to break down the steps of proving if two triangles are congruent, number one, first thing you're going to do is you're going to mark any extra congruent parts. So we're going to be looking for vertical angles or shared sides. Next thing you're going to do is you're going to label each marked part as a side or an angle. That's going to help you determine which postulate to use. Then you're going to decide if there's enough information to prove congruent. Notice all of our postulates involve 3 letters, which means you have to have at least 3 pairs of congruent parts. So if there's not enough information, you're going to have to write not congruent or not enough information. If they are congruent, you're going to write the angle or side congruent statements with reason, so why they are congruent. So that information is either going to be given, or if you're using vertical angles or shared sides. And then lastly, you're going to write the congruence statement with the postulate. So example, if you conclude that the triangles are congruent, you're going to say triangle ABC is congruent to triangle DEF by whatever postulate you're using. So in this case, I gave the example of side, side, side. All right, so let's do a couple examples of what we just did. So first thing I'm going to do is I'm going to look at the diagram. I'm going to see if there's any other parts that I can mark. Well, I don't see any vertical angles or shared side, which means everything that is marked is going to be marked. Now I'm going to label each marked part as an angle or a side. So looking in the first picture, I see an angle here, and a side. Same thing here, an angle here, and a side. So then we have to determine which postulate to use. So it could either be angle, side, angle, or angle, angle, side. So if we look and see, the side that is congruent is the non-included side, meaning it's not the side between the angles, which means that this is going to be AAS. Okay, so now let's go ahead and write out our congruent statement. So angle B is congruent to angle U. That was given. Angle A is congruent to angle V. That was also given. And then lastly, the side AC. So we went from A to C, so it's going to be VT. That was also given. So that means these two triangles are congruent, and we're going to write our congruent statement. So triangle ACB is congruent. So let's see, I went ACB, so I need to go VTU. And then you can write, we already wrote it before, but you can say by AAS. All right, let's do one more example here. So first thing I'm going to do is I'm going to label any extra parts. So I don't see any vertical angles or shared sides. So now we're going to go straight to labeling our sides. So I see I have an angle here, a side, and a side. Same thing, I have an angle, side, and a side. So the only postulate that has 2 sides and an angle is SAS. And remember, for SAS, the angle has to be included. But as we see here, the congruent angle is not the included angle. It would have to be, the angle that we would need to be congruent would have to be angle J and angle X. So in this case, these are actually going to be not congruent. Okay, you can, if you want, go and write out the congruent statements, but since these are not congruent, we can't write a congruence postulate, nor can we write a congruence statement. Let's explain why they're not congruent, though. We're going to say not congruent because the angle, or the congruent angle, is not the included angle.